The graphics for the Nintendo Game Boy can be split into three main topics: the background tile map, the window tile map, and sprites. Each of these are rendered using 8x8 tiles that are stored in the Game Boy's video RAM, or VRAM for short. In my previous tutorial, we got a basic background drawn on the Game Boy screen. Before we get to drawing sprites, I want to show you how to do a little bit more with the background. In this video, we'll go over how to move the background and how to draw colored backgrounds for the Game Boy Color. The Game Boy screen is exactly 20 tiles wide and 18 tiles high. However, the Game Boy's background tile map is 32 tiles wide and 32 tiles high. To show tiles outside of the screen, we must move the background tile map. We have two common ways of doing this. We can use the move BKG function, or we can use the scroll BKG function. Both of these functions will change the position of the background. They also both take in two parameters, an X and a Y. The move BKG function will instantly move the background to the X and Y pixel coordinates specified. The scroll BKG function will move the background relative to its current position. The naming can be a little confusing at first, but you'll get the hang of it quickly. In our game loop, if we pass the same values to both functions, we'll see different behaviors. Increasing the X coordinates of the background moves it leftward. Increasing the Y coordinates of the background moves it upward. The next and final thing we'll go over in this video is drawing colored backgrounds. Drawing colored backgrounds is relatively easy, but it requires three additional things: compilation for Game Boy Color, color palettes, and an array of tile map attributes. There are two common ways of creating Game Boy graphics: using PNG to asset, or using the Game Boy Tile Designer and Map Builder. I'll go over those options in greater detail in a later video. Both of these options can generate color palettes and tile map attribute arrays for you. Once exported, color palettes will be defined as an array of unsigned 16-bit integers, and your tile map attributes will be an array of unsigned 8-bit integers. Let's cover compilation for Game Boy Color. You can specify that your game is compatible with Game Boy Color using one of the following arguments when compiling your ROM file. Once we've updated our compilation arguments, we need to set the color palettes in VRAM. The Game Boy Color supports a total of 16 different color palettes. Each color palette has 4 16-bit colors in it. 8 of the 16 color palettes are specifically designated for sprites, and the other 8 are specifically designated for the background and window tile maps. With that said, now we can get into some coding. In your main.c file, first we'll include the source files for our colored background image. Check out the video description below for a link to these files. After that, we'll put our background image's tile data into the Game Boy's VRAM. Include the Game Boy Color header file, and then set the color palettes into VRAM using the set BKG palette function. This function takes three parameters: the first palette to write to, which should be a value between 0 and 7. How many color palettes are you placing into VRAM? Maximum 8. And a pointer to the first item in the first color palette. Once you have your colors in VRAM, here's how you apply the colors to your background. To do this, we'll use our array of tile map attributes. These attributes can contain tile-specific operations and/or which color palette a given tile should use. Recall in the previous tutorial, we used the setBKG tiles function. We used this function to tell our background tile map which tiles in VRAM it should draw and where. The Game Boy Color has two areas in VRAM called banks for tiles and attribute data. We can use the VRAM bank register to change which VRAM bank we write to. We should write our tile set indices to bank 0 and our tile map attributes to bank 1. First, we'll temporarily change our VRAM bank to 1. Next, we'll call the setBKG tiles function and pass it our tile map attributes array. After that, we'll reset the VRAM bank back to 0. Finally, we'll call our setBKG tiles function again with our normal tile map array. If you compile and run, you should see our background has colors now. I hope you found this helpful. As always, if you need help, reach out in the comments or in the GBDK Discord server. Like and subscribe for more Game Boy game development videos. Have a good day.